Hi there, and welcome to another chapter of the electric BMW 320i project. Yeah, I know it's been a couple of months since the last video, and well, what can I say? It's summertime. Between vacation and riding my bike and golfing and doing other things, the 320 just takes a back seat and doesn't get much work done on it. Although, like one day on the weekend and a couple of nights a week, it's still making some progress. This week, or on this video, I will show some of the wiring I've done. In fact, most of the wiring is done, both the high voltage and the low voltage, as well as the wiring for the BMS, and some testing of some of those components, as well as some of the strapping up of batteries. So right now, all the batteries except the very front box are all put together and all connected, so it's getting closer to being an electric vehicle. Let's take a look. So here's the preparation for the BMS wiring. This multi-conductor cable, what I do is I carefully open it up and then cut out two pairs of wires, one for thermistor, one for voltage. And then just to be extra safe, I'm heat shrinking the ends that I cut that are going back. So looked like I thought I'd do this before strapping up, get the thermistors soldered onto here and everything ready, and then it'll be instantly able to put together once the batteries are strapped up. So here now I have the thermistor soldered onto the wire. I realized after I started making this up that battery voltage only needs one wire for measurement, not two. So fortunately in this cable I have extra wires, so that wasn't going to be a problem. This was the first one I'm doing. And for the thermistor, it will go into a brass bolt like this that has a hole drilled in the center. That will just be, after the bolt is torqued on to the battery strap, I'll just put that in there and epoxy it in. And for the voltage measurement, I plan to get some ring terminals like this, but of a big enough diameter that, for the M6 bolt. And then that will be how all this gets connected. I realized when I started to look at soldering up wires and I got the thermistor on here now, that actually this battery box doesn't get any voltage measurements made in it, just temperature. So I'll put up my diagram for my battery layout, and you'll see where I have the orange dots. Those are the battery terminals where the voltage is to be measured. So in the box that I have this first thermistor I put together, there's no voltages measured because of the way just the voltages. You want to have each segment be about 100 or so volts, and that's at a 3.5 charge voltage, so it actually won't ever see that kind of voltage. Like on that first node's 105 and so forth. So going on to different boxes, then there'll just be one wire part of the wire be split out for the voltage measurement, and then also one pair of wires split out for the thermistor. Here's a shot of the rear seat boxes that are now all strapped up. Here's the BMS line. Here's a little brass bolt that thermistor will get epoxied into. Still waiting on spade connectors. Just turns out the way this is wired that there's going to be two voltage measurements in this box. And then in the second box there's just a thermistor measurement. So both boxes now strapped up. Just have to work out the battery cables. Going to have a fuse. This is like midpoint in the battery pack. There'll be another one at the end on the output of the box from the trunk. Here's a problem I knew I was going to encounter with this battery box design, where the cable came in right at the same point as the batteries. The only way this could connect would be to this second battery, but you can't do a second battery because there would have to be a strap in here, and then that would be on top of a strap, and I just didn't think that would be a good idea. So I've come up with an alternative method where I'm actually going to come out to the third terminal, or third battery here, and I'm going to have some 1-inch standoffs machined out of copper, and that way that will connect to that battery, and then it straps to this one, and then that straps to that one, and then what I have is I'll have these jumpers here that will go from the first battery to the fourth, and make a nice, basically it just zigzags the voltage, but that's fine, and that should work. Now I just have to wait for the machine shop to make those 1-inch standoffs. Here's a look of how I solved my issue with the getting over the battery straps. I had these little copper standoffs made, just 1/2 inch diameter with a 1/4 inch hole, which is clearance for an M6 bolt, and they just stand right up and hold the battery cable for clearance over the straps, so it should work really well. Same torque on that, and that's about the most contact you can have is a 1/2 inch on the battery, so should be able to pass enough current. I'll be testing it all out. Now it's also the two boxes connected together with a fuse in between. Here's something I do when working in really tight corners like this, trying to get this cable on without shorting against these other straps. I just put some packing tape, just regular old plastic packing tape. Just cover up everything that you could possibly short out, and then there's no way that's going to happen. And then when you get done getting everything together, just take the tape off and it's ready to go. Here's another thing to do with the packing tape. I got a component like this that's sitting out until I get the plexiglass cover that goes in between the battery boxes here. I just put the tape over this fuse, which has all these nice open connectors, and that way if no tools or anything drop in there, they won't short out. In strapping up the batteries, I found that it really works out well to just start the strap on there, start the screw, and then go back with a cordless drill. A lot of these drills have a torque setting that you can set to, and that on these is perfect because you can just essentially get them down and then go back and touch them up with the torque wrench. And with this one, it's like almost only about a quarter, half turn I have to go with the torque wrench. So it makes it a lot faster putting the straps on the batteries. Another important point is the bit on this is non-conductive. And this being all plastic, it's another good safety feature. No way to actually drop it and then short out things. Another thing I found, like working on this big battery pack like this, is I have these pieces of plexiglass, thin plexiglass that I cut out, and I just like to cover up the other straps while I'm working. That way, any fumbling won't drop a battery strap across these, which now are up at not a full high voltage, but enough that, and of course these batteries have such a low internal resistance, you could, have a catastrophic meltdown. So just a good idea to work on that. And I'm going to finish this last row and this box will be done. Alright, now they're all strapped up. Go back and torque every bolt, little torque wrench, the heat shrink on the socket just as an extra precaution. This is probably should be coated too with something, but hopefully it's in my hands and I won't drop it. There we go, all torqued down. Well, there we go, almost all 54 batteries all strapped up. Still have to get the battery cables in, and just like the rear seat boxes, I'm waiting for the standoffs to be able to connect to the 2 points coming in. Hopefully those will get done this week, and then I can finish all the wiring of the boxes. Here's a look at what I finally got done for the connections for the BMS and for the voltages on the batteries. Here you can see one. It's basically a 5-watt 55 or 50 kilo ohm resistor, and that's just connected into that multi-connector or multi-wire cable. And there's another one in here. Just turns out that the way the voltages are, there's 2 voltage measurements in this box, but what I've been doing is setting this up to measure just a single temperature in each box, and that's in that thermistor that's in that brass bolt. So the only thing left to do with that is get some silver epoxy and epoxy that in. Here's a little better look at it in the trunk box. The 50 kilo ohm resistor, 5 watt, and really doesn't need to be that, with basically 100 volts for each of these nodes. And the 50 kilo ohms, that's just 2 milliamps, so like about 200 milliwatts. Shouldn't be any issue, but decided just to go a little bit bigger and not have any concern about that. Again, same thing, a brass bolt to have the thermistor stuck to, and that's just basically sitting in the middle of the battery box. Here's a look at my secondary contactor box. This is for all the heating in the car. The contactor on the right is for the PTC heater, and the one on the left is for the battery box heater. And the circuit in the middle is the blocking isolation and inductor circuit for the DC-DC converter. This is something that circuit that Jack put together, and it's a good way to keep the DC-DC converter discharging into the battery pack when you get sag in your battery pack when you accelerate. So that's what's in there. Potted up the inductor with some silicone so it doesn't move around. All of the voltage, all the wires are high voltage. The orange one is actually only 12 gauge, but it's got a jacket around it for isolation. Here's a look how the wiring is going. Got the secondary contactor box mounted. Wires all ready to run around the engine compartment where they need to go. And right now I'm starting to work on the wiring harness for the BMS. That's what all those wires here are for. DC-DC converter is all wired up except for the high voltage, and battery cables ready to go. Got to put the front box back in. All the wires are now crimped with the little cinch pins, and if I can just get my wiring guide right, it should work out. Well, after several hours wrestling at first, I ended up having to get something else. So this is actually now 2 days later to get this connector done. Boy, what a tough connector this is. They claim that you can use up to even 26 gauge wires, but I would say anything less than 18 is almost not repeatable or impossible to get in every time. Had some wires that were going no problem at all, and others that just would bend and not go into the gland. It's just really tough. So next thing to do is connect it to the BMS board and see if it reads everything. Alright, here we go. Got the BMS board connected. It's inside that cinch enclosure, and I snake out a USB so I could run it in the computer, but everything seems to be working right. Got it referenced back to the battery through a fuse, and see on my little screen here reading voltages and temperature. One voltage is negative because of the way I have to measure it. There's a new mistake found in the BMS board. So I do know of a possible rework on that, and I'm going to do that later today, but everything seems to be working good on it, and it's reading all of the voltages in idle batteries and all the temperatures. Finally. So final checkout of the JevQ and DMOC communication before putting it into the car. This is the JevQ I have, which is a cinch enclosure, and I have a 35 pin amp seal, which I had machined to fit into a blank for the cinch. And I also have on this round circular connector a USB. So only thing else that has to go inside is the patch antenna for the Wi-Fi, and that enables using the cinch connector for the JevQ. And now I tested this all out. It's communicating to the DMOC, so should be ready to connect up to all the wires in the car and get the DMOC and motor in. Here I'm testing out the wiring for the Delphi DC-DC converter. Have it connected up to a little contactor box, and then got another JevQ set up to run the Delphi code, and it's working. It's producing 6 amps of 13.4 volts charging that little battery. So looks like everything's working. CAN bus is active, and all the wiring connections, at least the wiring I've done so far, is correct. So that's one less system to worry about, which is good. This is why I'm waiting for the very last moment to put the motor and DMOC back in, because it makes it easy for me to work on the all the wiring inside the engine compartment. See, very easy for me to get in and out with my nice long legs and arms. But this is ideal because I can work here instead of having to bend over the outside and connect everything up. So that's what I'll be doing. Almost all the wires are done, probably only about another dozen, and we'll see how long that takes. Here's the last bit of the brake upgrade. Besides new stainless steel lines, finally got the transducer for the regen, the brake pressure transducer installed, and quite a struggle because of all the different types of connectors, types of fittings. For BMW, they use this very special, they call a bubble flare. It's a double inverted convex, not very easy to find or match up to other natural things like 1/8 inch NPT, which the T is for this pressure transducer, but I finally did get all the pieces. So one thing good about this, where the brake pressure transducer came out, I have these extra wires that were part of the original fuel pump and fuel sensor, and those can be used to connect to that, and I don't have to run any extra wiring. They already are run through the body of the car. So I just have to pick those off underneath the dash, and I'll have the pressure transducer for the JevQ all wired up. Here's a look at the engine bay. Just doing the last fit up of everything, making sure this front battery box still goes back in and has enough clearance to be able to get the motor and DMOC back in. Obviously when I do that I won't have that box there, and that's why there's no batteries in it. But I got my bus bars for the power distribution, as well as high voltage fuses mounted on the battery box. And like, why not? It's a nice big structure. It's going to be well secured in place. Most of the high voltage wiring is done. See the DC-DC converter there. And a lot of the 12 volt wiring is done. Just have a few more wires to run, and the last thing will be connecting up the JevQ, but that will probably come after I put the motor in, because I'm going to be mounting the JevQ to the side of the DMOC. But everything else is about ready to go, and maybe another week it should all go back in, hopefully. Well, that was quite a bunch of stuff. A little bit longer video than normal, but well, it's been 2 months and I do record things as I do it. You can see that engine bay is getting very crowded, and it's going to be interesting when I get the motor and DMOC in there. Right now my measurements show I have still 1/2 inch all the way around, so we'll see what happens. You know, it's so close now with all the wiring done, at least except for the JevQ being connected, that should be able to, probably in another week, might be able to get the motor in it and DMOC and get that all connected and actually start spinning the wheels again, and maybe get it out for a test drive. So hopefully that will all happen in the next video and you'll get to see that. So thanks again for watching, and we'll catch you later.